Welcome to Earl Samm Plus. This is Earl Samm. Today we are going to learn how to integrate natural logarithmic functions. Okay, so let's do it together. Now, watch. When you integrate 1 over x with respect to x, the answer is ln x plus c. Okay, so this is what you need to know. And now in some cases you have let's say you have to integrate 1 over 5x, for example, with respect to x. Now this is 5x, like u. So you're going to differentiate this 5x. So, okay, in this case, what you have is ln 5x multiplied by the inverse of the derivative of this 5x. So if you differentiate 5x, you have 5, so you use 1 over 5, the inverse. So this will give you what? 1 over 5 ln 5x. Okay, plus c, don't forget, plus c. So I really hope you understand. So when you have another extra function, when you have an extra function, you differentiate that function and multiply your integral by the inverse of it. Another example would be, let's say you have to integrate 1 over, let's say 3x, let's say plus 2, for example, with respect to x. Now the 1 over implies that you have ln 3x plus 2, right? Now you now multiply this by the inverse of the derivative of this 3x plus 2. If you differentiate 3x plus 2, you have 3. And your answer is simply 1 over 3 ln 3x plus 2. Don't forget the plus c. Plus c, very important. So that's how we integrate these logarithmic functions. So with this, your 1 over x, you have ln x plus c. So now we're going to apply it to solve these problems. Now looking at this, I'll solve question 1, I'll solve question 2, that will be enough examples. Then I'll allow you to do number 3, then I'll come back to do number 4 and number 5. So you're only doing number 3 yourself, and I'll be expecting your answer in the comment section. So let's begin quickly. Okay, number 1. We are to integrate 1 over x plus 8 with respect to x. So it's straightforward. Our answer is ln the x plus 8. Remember, multiply by 1 over, if you differentiate x plus 8, you have 1. For differentiate x, you have 1. This 8 will get 0. Plus c. And then your final answer is ln x plus 8 plus c. So that's a straightforward one. So that's number 1. So remember I said I'm going to do number 2 also. So let's see number 2. Number 2, we have to integrate 6 over 2x minus 5 with respect to x. Now this is not a 1. So what do? We need to make it a 1 so that we can use our natural logarithms. So this will simply give us 6 multiplied by 1 over 2x minus 5 with respect to x. We have not integrated yet. We just rearrange so that we have our 1. So this will give us 6 multiplied by, when we integrate this, we'll have what? Ln 2x minus 5 multiplied by 1 over, don't forget, if you differentiate 2x minus 5, you have 2. Differentiating 2x gives us 2. The 5 will give us 0. Yes, plus c. Now this will give us 6 multiplied by 6 multiplied by 1 over 2. Yeah, this 1 over 6, 1 over 2. Then we have ln 2x minus 5 plus c. 6 multiplied by half, that's 3, right? So we have 3 ln 2x minus 5 plus c. And that's our answer. So it's not as difficult. So I've done numbers 1 and 2. Now I'll allow you to do number 3. Now if you don't know how to resolve this 2 and 1, you pick hints from what I'll do in numbers 4 and then numbers 4 and 5. But this number 5, I want us to do it together because it's a very interesting problem. So let me rub the board to do number 4. So number 4 says evaluate number 4 says evaluate 0 to 5. We have 1 over x minus k plus 2 with respect to x. Okay, now to evaluate this, we'll do the same thing we've been doing. Now we have boundaries from 0 to 5. So what we'll do, the same thing we've done, we'll replace our x with 5 minus, we'll do the same thing, replace with 0, and then we go. So let me just show it. So this will give us, first, if we integrate 1 over x plus 2 to give you ln x plus 2, right? Multiplied by, if you differentiate x, you have 1. Sorry, 1 over, differentiate x, you have 1. So we're going from 0 to 5. Now, there's no plus c because this is called definite integral. The ones where you have plus c, those are indefinite integrals. So for the definite one, you don't have a plus c, rather you have your actual value. Okay? So this will give us 1 over 1 is 1. So at the end of the day, we'll have ln x plus 2 from 0 to 5. Now, first thing we'll do, we'll pick this value now, replace our x with 5, minus same, replace our x with 0. So this is it. So what we're going to have is ln x is now 5 plus 2 minus, we do the same again with 0, ln 0 plus 2. So our x is 5 in the first case, and our x is 0 in the second case, and you are subtracting. So that's how it works. So this will give us ln 7 minus ln 2. And remember, ln is just like logarithm. Ln is logarithm, natural one. So ln 7 minus ln 2, that will be ln 7 over 2. Okay, so this works like log. So log 7 minus log 2 is log. Remember, when you are subtracting, you divide the arguments of the log, 7 over 2. The same thing we have done here. And this is our answer. Yeah, I know this is easier than you thought. Yes, it is. So we're going to do number 5 together now and end this class. So, but remember, I'm waiting for your answer to number 3 in the comment section. So let's do number 5. So number 5 says integrate or find from 10 to 4, we have 2 plus 5 over 5 over 3x minus 2 with respect to x. Okay, so what I'll do first, I'll first of all rearrange to what's familiar, and then we solve. So this will give us we can share both 2 and this, we can break it. So we'll have ln 10 to 4 of 2 with respect to x plus, that's this one now, plus this other one, 10 to 4 of 5 over 3x minus 2 dx. Remember, we're adding our c, right? So let's integrate this. This will give us, if you integrate 2 is 2x raised to the power 0, right? So it's become 2x raised to the power 0 plus 1 over 0 plus 1, and then you have 2x. So if we integrate this, we have, okay, before we integrate, let me do one more. 10 4, we have 2 dx plus, here remember, we can say this is 5 10 4 1 over 3x minus 2 dx plus c. So I think we've done this earlier where this 5 we brought it outside because 5 multiplied by 1 is still 5. So we want it to come in a form where we can use our natural logarithms. Okay. So let's integrate now. Remember, for the boundaries, you replace with 4 with 10 and 4. So but we'll integrate first. So this will give us, if you integrate 2, you have 2x from 10 to 4 plus, this other case, we have 5, this 5 now, into, if you integrate this, you have ln 3x minus 2 multiplied by 1 over, if you differentiate 3x, you have 3, right? Differentiate minus 2, it gives you 0. And don't forget that we're going from 4 to 10. Okay, so please write down this question. This is the one I'm expecting you to solve. So I want to rub this part, so we'll just finish up here. One more line, right? Okay, so this will give us, first we replace our 10. So 2 multiplied by 10, that's 2x, x is 10, minus the second case, 2x, x is 4. So this is this first part before the plus sign. Okay, let me do it this way. So we've resolved this part. Plus, we want to resolve this other one. Now we have our 5 out there. Let's leave the 5. Okay, so let's replace our x with 10. So we'll have 1 over 3. This 1 over 3 now. Ln 3 multiplied by 10 minus 2. First case minus the second case now where x is 4. We'll have ln 3 multiplied by 4. Our x is 4 minus 2. We'll close this. Now take note that this 1 over 3 is not strictly for this. But the 1 over 3 is for everything. So it will choose the 1 over 3. In fact, we should have brought the 1 over 3 out. So which is what we're going to do. But let's continue up here. Okay, so in this first part, we have 20 minus 8. That's what we have here. Plus, on the other part, we have 5 multiplied by 1 over 3. I'm bringing that 1 over 3 out. Then we'll have ln 3 multiplied by 10 is 30. 30 minus 2, that's 28. Watch, 3 multiplied by 10 is 30. 30 minus 2 is 28 from this bracket. Minus lane. 3 multiplied by 4 is 12. 12 minus 2 is 10. So we'll have 20 minus 8 is 12 plus 5 over 3. That's 5 over 3. Lane. Remember, when you are subtracting two logarithms, you divide their argument. So 28 over 10. So 2 in 10 is 5. 2 in 28 is 14, right? Yes. So we'll have 12 plus 5 over 3 lane 14 over 5. And that's our answer. Okay, so I remain Earl Samm of Earl Samm Plus. Kindly subscribe to this channel to keep getting interesting solutions to mathematical problems. So I'm waiting for your answer to question 3 in the comment section.